Welcome to another 10 minutes of useless space facts. Warp drives, or faster-than-light transportation methods, are theoretically possible. By stretching space in such a way that a bubble is formed travelling faster than light, a spaceship inside this bubble could travel comfortably at 10 times the speed of light without experiencing any relativistic effects. This is because the spaceship itself is not actually moving. It can instead help to think of the ship as being carried on a wave of space-time. Unfortunately, this can lead to some causality breaking scenarios, due to certain geometric realities that would allow information about events that have not yet happened to be received by one observer from another. It seems that the universe conspires to prevent this from happening, as an Alcubierre drive that allows for faster than light travel would require negative energy, and therefore negative matter, which simply does not exist as far as we are aware. The most suitable stellar systems to look for life in are orange dwarf systems. Yellow dwarfs, like our Sun, have relatively short lifespans of only around 10 billion years or so they may not provide the best opportunities for life to form, and our existence may be a rare exception. Red dwarfs live the longest, with lifespans of trillions of years. However, planets need to orbit very close to receive sufficient heat and light, and red dwarfs are extremely violent stars, with flares that put the Sun to shame. These violent outbursts occur in the early stages of the red dwarf's life, which means that life will probably not prosper on these planets. Orange dwarfs, however, are far less violent, and have a more respectable brightness and temperature. They also have lifespans double that of our own Sun, around 25 billion years or so. This makes them very nice candidates on the search for life. As you might already know, time is relative. In reality, everything is relative, and depends on your perspective. Gravitational pull, for example, is simply an acceleration of space-time towards a center of mass. Your weight on Earth is simply what it feels like to accelerate against the constant contraction of space-time into the Earth. The atoms in your body have a pressure that pushes against this acceleration. The Earth also resists this acceleration of space-time, and in doing so, it grows outwards. Depending on our perspective, we can say that the Earth is constantly growing at 9.81 meters per second, and it's not that we fall to the Earth, but that the Earth is expanding constantly towards us. The reason the Earth doesn't get any larger is because it grows into a constantly contracting space. On the topic of relativity, you might know that the faster you go through space, the more contracted the universe appears to become. From a stationary observer's perspective, you are the one becoming more and more contracted the faster you go. From your perspective, the universe becomes more and more contracted, or shortened. So if you were to travel at the speed of causality, or the speed of light, the universe would be so contracted that it would simply be completely flat, and you would reach your destination before you even left. This is how photons experience no time. From their perspective, the universe is so flattened, it is two-dimensional, and they are at the beginning and the end of their journey simultaneously. The tallest mountain on a neutron star is not even a millimeter tall. This is because neutron stars are the densest objects in the universe, excluding black holes, and have therefore got extremely strong gravitational fields. If you were teleported onto one, and were invulnerable to heat, you would be flattened onto its surface immediately, and would become part of the dead star. A magnetar is a neutron star with a very strong magnetic field. So strong is its magnetic field that at around 1,000 kilometers away, this object would be lethal at an atomic level, stripping your atoms of their electrons and causing a very strange death. There are more trees on Earth than there are stars in the Milky Way, and more chess moves than atoms in the universe. Slightly off topic, but still quite fascinating nonetheless. The nebulae we see from Earth, like the Orion Nebula, are giant accumulations of dust and gas in space, which from a distance look quite dense. That's because relative to the rest of the interstellar space, they are. But appearances can be deceiving, because if you were to be inside one of these regions, you wouldn't really be able to tell. In fact, the density of gas in these regions is only several hundred million atoms per cubic centimeter, or in other words, what we would call a perfect vacuum here on Earth. In normal interstellar space, there is about 1 atom per cubic centimeter for comparison. On Earth, we enjoy a nice 10 million trillion atoms per cubic centimeter. As you may know by now, I like talking about stars, but did you know that the star Vega rotates so fast, around 960,000 kilometers per hour, at its equator, that it's actually egg-shaped? There are many reasons for us not having found extraterrestrial life yet, ranging from existing at the wrong time, to simply being too far away to communicate. But one reason that is often glossed over is the fact that we don't really know just how different other life forms can be. For example, there is a small chance that life can exist inside stars, conscious beings that arise from the cosmic strings that form three-dimensional structures and undergo the same evolutionary processes we do, on different timescales. We don't really fully understand the limit to what can and can't be alive after all. We don't really understand consciousness, or just the extent of what can and can't be conscious. You may know that sunsets on Mars are blue, but on Venus they are instead a browny-orange colour. You also don't want to miss these sunsets, since you'll only get one around once every 115 days. If you were to jump on Mars's moon Phobos, you'd reach a whopping 773 meters before finally falling back down. If you run and jump fast enough, you might even escape its gravitational pull altogether, as the escape velocity is around 40 kilometers an hour. Extremely massive stars of 8 solar masses and above will eventually fuse silicon and helium into iron as they begin to run out of fuel and die. It is thanks to these stars' deaths that we can have some of the heavier elements that allow for the existence of life and planets. Our sun will stop fusion at carbon, however these massive stars don't stop at iron, and they create heavier elements like copper and nickel, although most of these are unstable isotopes that decay into iron-56. The time these stars take to fuse hydrogen into helium is millions of years. Helium fusion lasts for hundreds of thousands of years. Carbon fusion is hundreds of years. Oxygen is just a few months, and silicon fusion is only a couple of days. After this, the massive star collapses in on itself. If you're wondering how very heavy elements are made, like lead, you must look towards lower mass stars. Surprisingly, stars that don't go supernova, and which are partially made up of iron and elements created by earlier stars, can go all the way up to lead. Extremely massive stars simply don't have enough time to produce some of these elements before going supernova. This neutron absorption happening in lower mass stars accounts for half of the elements beyond iron. The rest are created inside neutron star collisions and supernovae. Anyway guys, that was another 10 minutes of space facts. Hope you enjoyed, and thanks for watching.